We now continue our look at Alberta's Science 9B3 on the chemical nature of matter by looking at creating models. Specifically, students will distinguish between observation and theory and provide examples of how models and theoretical ideas are used in explaining observations. For example, describing how observations of electrical properties of materials led to ideas about electrons and protons. Describe how observed differences in the densities of materials are explained, in part, using ideas about the mass of individual atoms. Introduction. When studying science, it is important to understand the difference between observation and theory. Observations are facts or data that we collect using our senses or scientific instruments. For example, we might observe that a metal wire conducts electricity, or that water boils at a certain temperature. Theories, on the other hand, are explanations or models that scientists develop to make sense of these observations. Theories help us understand why things happen and allow us to predict what might happen in new situations. It's important to emphasize these ideas don't start as theories. They start as conjectures or hypotheses. They don't graduate to being called theories until they've been shown to explain observations time after time after time after time. It really is the strongest term available in science, even though the colloquial use of the word is much weaker in terms of confidence in that idea. Now, observations versus theory. Observations are the starting point for scientific investigation. They are things we can see, measure, or record directly. For example, if you notice that copper is a good conductor of electricity, that is an observation. If you measure the density of iron and find that it is higher than the density of wood, that is another observation. Theories are ideas that explain why these observations occur. They are not directly observed, but are developed by scientists to make sense of the data. For example, scientists cannot see electrons with their eyes, but they develop the theory of electrons to explain why some materials conduct electricity and others do not. So, how models and theoretical ideas explain observations? Scientists often use models to help explain their theories. A model is a simplified representation of something complex. Models can be physical objects, diagrams, or mathematical equations. They help us visualize and understand things that are too small, too big, or too complicated to observe directly. Let's look at some examples of how models and theories are used to explain observations. Example 1. Electrical properties of materials. Start with our observation. Some materials, like copper and silver, conduct electricity very well, while others, like rubber and glass, do not. Theory. Scientists developed the idea that electricity is caused by the movement of tiny particles called electrons. The electron theory explains that metals have free electrons that can move easily through the material, allowing electricity to flow. In contrast, materials like rubber do not have free electrons, so electricity cannot flow through them. The model. The atomic model of a metal shows items arranged in a lattice, with electrons moving freely between them. This model helps explain why metals conduct electricity. Example 2. Density of materials. Our observation. Different materials have different densities. For example, iron is much denser than wood. Theory. Scientists explain this by considering the mass and arrangement of atoms in each material. The theory of atomic structure tells us that iron atoms are heavier and packed more closely together than atoms in wood. The model. The mathematical model for density is that density is the ratio of mass and volume, so mass divided by volume. By measuring the mass and volume of a material, we can calculate its density. The atomic model helps us understand why some materials have more mass in a given volume than others. Example 3. Chemical reactions. An observation. When hydrogen and oxygen gases are mixed and ignited, they react to form water. Theory. The atomic theory explains that hydrogen and oxygen atoms combine in a specific ratio to form water molecules. This theory helps us understand why the reaction produces water and not some other substance. Model. The chemical equation for this reaction is 2 hydrogen molecules. The 2 in front is how many molecules we have. That subscript 2 after the H is how many hydrogen atoms are in each molecule. So we take 2 molecules that have 2 hydrogen atoms each. We add 1 oxygen molecule, which also contains 2 oxygen atoms. When they react, it produces 2 water molecules, which is made of 2 hydrogen atoms and 1 oxygen atom. This model shows how atoms rearrange during the reaction. So, why distinguishing between observation and theory matters? Understanding the difference between observation and theory is important because it helps us think critically about scientific information. Observations are facts, but theories are explanations that can change as new evidence is discovered. For example, the theory of atoms has changed over time as scientists have made new observations and developed better models. This does not change the observation. This just changes how we explain the observations. Sometimes those observations lead to entirely new theories. For example, when scientists observed that electricity could flow through some materials but not others, they developed the theory of electrons. Other times, theories help us make new observations. For example, the theory of atomic structure led scientists to look for new elements and discover new materials. In conclusion, in science, observations and theories work together to help us understand the world. Observations are the facts we collect, while theories are the explanations we develop to make sense of those facts. Models are useful tools that help us visualize and understand theories. By distinguishing between an observation and theory, and by using models to explain our observations, scientists can build a deeper understanding of nature and make predictions about how things will behave. This process is at the heart of scientific discovery and helps us learn more about everything from the smallest atoms to the largest galaxies. Now, as always, we'll wrap up with a check for understanding. What is an observation in scientific terms? Is it a detailed explanation of a phenomenon, a guess about future events, a mathematical model, or information gathered using the senses or instruments? Pause now if you need more time. It is information gathered using the senses or instruments. Which of the following is an example of a theory? Gravity causes objects to fall. Leaves are green. The sky is blue. Water boils at 100 degrees Celsius. Pause now if you need more time. The theory is the first one. Gravity causes objects to fall. It's the explanation of the observation that objects fall. How did observations of electrical properties lead to the development of atomic theory? Is it by demonstrating that atoms are visible? By proving that atoms are made of water? By showing that atoms are indivisible? Or by suggesting the existence of electrons and protons? Pause now if you need more time. Yes, it was by suggesting the existence of electrons and protons. Which model helps explain the differences in densities of materials? Is it the atomic model, the food chain model, the solar system model, or the water cycle model. Pause now if you need more time. It is the atomic model that helps us explain the differences in densities of materials. How do theoretical ideas help in explaining observations? They are only used in chemistry, they eliminate the need for experiments, they provide a framework to understand and predict phenomena, they replace observations with guesses. Pause now if you need more time. They provide a framework to understand and predict phenomena. If your ideas cannot predict what will happen in certain situations, nobody will take those ideas seriously. It will never achieve the status of scientific theory. This wraps up this video on creating models. If you have any questions or feedback, please leave them in the comments. I would be very happy to go through them, and I will try to respond in a timely fashion.